All right, what we're going to have here is 3 equations with 3 unknowns. And then we're going to need to solve them. So first, the sum of 3 numbers is 16. Now, I don't know what these numbers are. I'm going to call them x, y, and z. So if I take x and y and z, and I take the sum of those 3 numbers, it will equal 16. That's my first equation. Then it says the sum of twice the first number, that's 2x, 5 times the second number, that is 5y, and 6 times the third number is 59. So plus 6z equals 59. Okay, this is the sum of twice the first number, 5 times the second, and 6 times the third is 59. All right, that's my second equation. Let's get to the last equation. Let me erase this brown stuff. All right, last equation. The difference means subtraction, between 4 times the first number and the second number is 27. So this is going to be the difference between 4 times the first number and the second number. Okay, look at this. The difference between 4 times the first number and the second number. Since they mentioned this one first, it goes in front. All right, so the difference between 4 times the first number and the second number equals 27. All right, find the 3 numbers. So now I have 3 equations and 3 unknowns. All right, I'm going to label my equations A, B, and C. Okay, so let's come up with a strategy. I see that down here in my third equation, I have an x and a y with no z. So what I'm going to do is I'm going to use the first 2 equations to eliminate z. And when I get that, I'm going to take whatever I get along with this one down here, and I'll have 2 equations with 2 unknowns that I will know how to solve. So let's look at A and B, and remember I'm going to eliminate z. So here are our A and our B. We want to eliminate z. So if we add them together right now, would our z go away? No. We'd have 1z and plus 6z gives me 7z. So it doesn't cancel out. So what I'm going to need to do is change one of these equations so that the z cancels out. In order to do that, we're going to need to multiply the top equation times -6. Okay, the reason I'm doing that is because this will be a -6z added to a 6z. That will cancel out. So let's distribute -6 throughout the top equation. All right, I'm going to move my system over here. So -6 times x is -6x. -6 times y is -6y. -6 times z is -6z. And then most importantly, don't forget, -6 times 16. And that's going to give me -96. All right. My equation B is fine just like it was, so let me write that down here. 2x plus 5y plus 6z equals 59. And now I am ready to combine these two. I'm going to use addition, and the z's should eliminate. -6z plus 2z, well, that's -4. I'm sorry, -6x plus 2x is -4x. -6y plus 5y is -1y. And then -6z plus 6z is 0. Negative 96 plus 59. Get my calculator. That's negative 37. All right, so now I have this equation with an x and a y, and I have this equation with an x and a y. I'm going to put those two together, and I will be able to use elimination or substitution to find the answer to one of my variables. So let's go ahead and put them together. I'll do it down here. And they are already set up for one of these variables to cancel. If I add these two together, look at what happens. 4x minus 4x, gone. Now I have negative 1y minus 1y, that's a negative 2y, equals 27 minus 37, negative 10. So negative 2y equals negative 10. Let me divide both sides by negative 2. And y will equal 5. So I'm in my answer, I'm going to have an x, a y, and a z. I'm going to have three numbers. And I've just found out that y is 5. All right. If I had an x, y, and a z, y is 5. X, y, z. Now, let's use that 5. Let's plug it in, and let's find x. Okay, now I can use either one of these equations that are circled in yellow. All right, you see how I have an x and a y, and if I plug in the y, I will be able to find x. I'm going to use this one up here. So 4x minus y equals 27. Let me make some space here, separate this a little bit. 4x minus y equals 27 equals, and my y is going to be 5. So 4x minus y equals 27. And for y, I plug in a 5. And now I solve this equation. Let me add 5 to both sides. So now I will have that 4x, right, that drops down here, equals 27 plus 5 is 32. Divide out the 4. Get red. Divide out the 4, divided by 4, divided by 4. So these two cancel. Now x equals 32 over 4 is 8. So my first number, x, is 8. And then the last number, z. All right, and now I can plug it into any one of my original equations, this one or this one. I'll go ahead and plug it into the top one here. It looks simpler. X plus y plus z equals 16. X is 8. X plus y plus z equals 16. Okay, x is 8. Y is 5. Solve this. 8 plus 5 is 13. Plus z equals 16. Subtract that 13 from both sides. And z is 3. That was my drum roll. Z is 3. Okay, here are the numbers. All right, and when they ask you what the numbers are, the first one has to be 8, the second one 5, and the third 3. All right, and I bet you the sum of these three numbers will be 16. The sum of twice the first, 5 times the second, and 6 times the third, that will give you 59. And the difference of 4 times the first and the second one is going to be 27. All right.